I want to look now at a second method for factoring trinomials where that leading coefficient on the x squared is not 1. And this method is based off factoring by grouping, which we often use when we have 4 terms to factor, as we do in this example. And what we do when we do factoring by grouping is that we try pairing up 2 terms and we look for a greatest common factor. So in my first 2 terms here, I can see that x squared is common, so I pull that out, and that leaves me with x minus 2. And on these second 2 terms, I can see that the common factor would be plus 2, and that will leave me with x minus 2 as well. And you'll notice here that we have a common factor of x minus 2, which we can then pull out. And then we know x minus 2 times x squared will give me this, and x minus 2 times 2 will give me that. And I have my polynomial factored. So we can use this idea of grouping terms with trinomials as well. And the way it would work here, because we only have 3 terms, is we're going to look for 2 numbers that multiply to give us the product of these 2 numbers, the leading coefficient and the constant. We're going to look for 2 numbers that multiply to 6, and the same 2 numbers that add or subtract to 5. And if we think about that, 3 and 2 would work. And then what we're going to do is we're going to take the 5x and we're going to rewrite it as 3x plus 2x using those numbers I just found. And let's bring in the 2x squared at the front and the 3 at the end. So we've turned our trinomial into 4 terms, which we are now going to group. So we're going to pair these up. And you'll notice that in the first 2 terms we have a common factor of x, which leaves us with 2x plus 3. And in the second term we have nothing common, so we just have plus 1, which would leave us with 2x plus 3. And we now have our 4 terms down to 2 terms in which we have a common factor of 2x plus 3, which we can pull out. And then 2x plus 3 times x will give me this. And 2x plus 3 times 1 would give me this. And I then have my polynomial factored. If I multiply this out, I will get what I began with. Let's practice this method of factoring with another example. We have a leading coefficient which is not 1, which is a classic time when we would use this technique. We are going to look for 2 numbers that multiply to give us the product of the leading coefficient and the constant, 2 numbers that multiply to 24, and the same 2 numbers which add or subtract to negative 14. So we spent a few minutes thinking about what those numbers would be, and we know that 12 and 2 multiply to 24, add or subtract to negative 14, but we would need negatives on all of those. Alright, so we're going to break up our negative 14x. We're going to decompose it into negative 12x minus 2x using the 2 numbers we just found. Break it up into 2 terms. That's why we call this method decomposition. We're breaking it up into 2 other terms. So we're changing the polynomial from 3 terms into 4. Because now we're going to try to group pairs. And a common factor on the first 2 would be 3x, leaving us with x minus 4. And we know that we need to get an x minus 4 over here for this method to work, and that would happen if we factored out negative 2. We now have our polynomial from 4 terms down to 2 terms, and the good news is we have a common factor which we can pull out, x minus 4, leaving us with 3x minus 2.